All right, here we go. Okay, so again, here we have, right? Hold on, can you hear me? All right, I thought I forgot to turn the, what do you call it, the microphone on, so, but it's on. So again, this is the problem that we're working on, right? We want to take out $1,500 each month from our account, right? And this is going to happen for 25 years, okay? You know, it's a retirement account, let's say. And this account earns 6% interest. How much do we have to have in the account when we retire? In other words, how much do we have to have in the account in the beginning? That's really what we're after. I said retirement account. Off the top of my head, I don't know any other examples of payout annuities. I'm sure there are many examples though. But again, we're making many withdrawals. That's why it's a payout annuity. So we have our formula. Okay, so from here, we know what PMT is, right? That's our that's our $1,500, right? This is going on for 25 years. That's why our T is 25. 6% interest. Our R then is 0.06, right? We don't know what P0 is. That's what we're after, right? Now, since we're taking money out each month, right? By our assumptions, the account is going to be compounded monthly. So in this case, our N is 12. Plug it into the formula, we get this. So we have to calculate this thing. Okay, so again, what do? We can calculate top and bottom, right? Order of operations. So the 0.06 over 12, I just calculated that directly here. The exponent, right? That's going to be negative 300, okay? As you can see. So we do 1.005 to the negative 300. That I did in my calculator. We end up getting this 0.22 number. You know, you're working from the inside out, right? Parentheses, right? Then you do the exponents here. We do these parentheses, right? That's what we get down here. Then we multiply top and divide the bottom and stuff, and we end up getting this amount. And so we do it one step at a time, right? We do 0.06 over 12, right, for the bottom and the top. In the top, we also add 1. That's how we get the 1.005 here. Okay, so what's the next step here? The innermost parentheses. We have negative 300, right? And that gives us this number here. Okay. Notice I'm using way more than 2 decimal places. Here I'm using, it looks like, is 8. Okay. You want to use as many as you can. I'm not saying you have to use like 10 or 20, but you know, using like 5, 6, or 8 would be good, or even 9. You know, because you want your answer to be as accurate as possible. Also, we're rounding at the end to 2 decimal places, but I'll remind you that on the exam. We do 1 minus this, then we do all this quotient and division. We do this product on top, then the division. We get this. So that's how much we need initially. All right. So that's what the formula, okay? Now, let's use the Tvm solver. What I'm going to do now is actually, no, I'm not going to do that yet. I'm going to do this. Sorry. I was going to stop sharing and go to the Tvm solver, but we got to do this first. So for the TBM solver, right? Well, again, PV is how much is in the account initially, the starting balance, right? But that's what we want to know. That's our unknown. So for PMT, right? Well, that's our $1,500, $1,500, right? That's going to be positive because that's coming to us. That's what they call the cash inflow to us. Capital I, 6%. As you can see, you leave that as a percent here. Capital N is little n times t. Little n is how many times, no, that's right. Little n is how many times it's compounded a year. We're making withdrawals each month, right? So by our assumptions, it's going to be compounded each month, 12 times a year. That's where this 12 comes from. 25, right? This is going on for 25 years, okay? You know, n times t, right? N is 12, t is 25. Yeah, we want FB to be 0. Now, why is that? Because after all this, we want to have nothing left over in the account. You know, in theory, we want to run through all the money. I mean, does that normally happen in real life? Honestly, I don't know, but theoretically, that's what should happen. And since it's being compounded monthly, both of these here equal each other, and they're equal to 12. So let's put this in the Tvm solver. All right. Here it comes. All right, let's use the Tvm solver now. So we'll clear everything. So we said n was 300, right? I, we said, I think, was 6. PV is what we're looking for. PMT was 1,500. Okay. FB we leave as 0. These two we said are both equal to 12, right? And they're always equal to each other, in this class at least. I mean, theoretically they don't have to be, but for this class we'll keep them the same. Excuse me. So PV is what we want. We get the same amount, right? We get negative 232,810.3. Make sure you click in the box also, because you can see that it looks like there's nothing after the decimal, but there is. And I know there's a negative there, but the negative we can really leave off. So we get something. Where is it? Oh, there. So we end up with, let me go back to the lecture slides. So we end up with, you know, same things before, $232,810.30. Any questions on this? Because next we're gonna work with loans next. All right. So we're gonna look at loans now. Now we did actually look a little bit at loans earlier, right? You know, when we looked in chapter 5, simple interest, compound interest, right? There, we were able to calculate the interest initially. I mean, there it was examples like you borrow $1,000 from a friend at simple interest. I don't know, it was 8%. We knew it was going to go on for a certain amount of time, like 10 years. We were able to calculate the interest up front. Okay. Here, though, we're going to get a little more realistic, mostly because with loans here, we're going to assume you can make monthly deposits, or you can make payments back to the loan, you know, like monthly, yearly, things like that. So we're not going to have the full interest up front, in other words. as I have here, this is one kind of example. You know, we can borrow, let's say, a certain amount, say $1,000, 12% annual interest rate. So this is the APR. And just like before, we're going to assume it's going to be compounded. The loan will be the balance with the same frequency as we make payments. But again, you're not going to calculate the interest initially, you know, the total interest. We're not going to pay it all back at once. We're going to pay it back gradually. You know, we're going to make monthly payments, for instance. That's what we're going to assume in Chapter 6. What I want to do first is go through the calculations just to illustrate what's happening. The loan formula is actually going to be very similar, almost identical to the payout annuity formula. Okay.